Hello learners, welcome to this course on embedded system design using AT89C51 microcontroller. In this tutorial, I will be discussing about how to build a water tank level control system. So first let us try to understand the methodology of a water tank level control system. So let us take a water tank and we are going to fill water into the tank based upon the sensor inputs. So we are going to place two sensors, one at the bottom at 10% water level and another one at the 90% water level. There is a reservoir where we have kept the water, and the water will be pumped from this reservoir into the water tank depending upon the status of the sensors. There is a controller system which we are going to design in this tutorial. So depending upon the sensor values, the water will be pumped from the reservoir and it will go into your water tank. And in order to have the drain functionality from the water tank, we are going to use another motor, and by activating that motor we are going to assume that the water will flow out of the tank. So let us take a simple water tank here. So I am going to connect two switches, S1 and S2, or two sensors which are like a digital sensor, switch based sensors. When water reaches that level, it will give 1. When the water is not going to reach that, it will give 0. So we are going to have a switch as a sensor here. And there are going to be two motors, motor M1 for putting the water onto the tank and M2 for draining out the water from the tank. So in order to build this operation, we have to construct a state machine. So for constructing a state machine, I try to take few options, like the motor M1 is an inlet motor. If I give a value of 1, it will be in on state. If I give a value of 0, it will be in off state. Same way for motor 2, which is an outlet motor. 1 means on, 0 means off. For sensors S1 and S2, so S1 is the sensor at the bottom at 10%. 0 means the switch is pressed or the switch gets activated due to water. When it is 1, switch is non-active. Same way for S2, sensor at the top at 90%. 0 means switch is active, 1 means 0, switch is non-active. So we define 4 states. In the initial state, S1 and S2, these two are switches, and M1 and M2 are motor condition. So when I don't have water in my tank, my switch 1 and switch 2 will be both in open circuit. So thereby it will be at logic 1. So in that case, my inlet motor operates. Outlet motor is in off condition. So the water starts filling up. When the water starts filling up, when the water touches this S1, what happens? S1 gets activated, whereas S2 is not activated. So when the water reaches S1, still I continue with my motor M1. So the water gets poured onto the tank, whereas M2 is in off state. So as the water starts rising, once it reaches S2, what happens? Now both S1 and S2 both are active. In that case, what I am going to do? I am going to switch off the motor M1 because it is almost 90% of the tank is filled. So I am going to switch off M1 and I am going to switch on M2. Thereby the water will get drained. Then when it gets drained, what happens? The water level reduces. So when the water comes down below your S2, what happens? Your S1 will be in on state, whereas S2 will be in off state. In that case also, I want to still continue with the same operation. M1 will be off, so inlet of water into the motor will be off, whereas M2 will be on. So the water will get drained. So water will slowly reduce from the tank Once it reaches below S1, what happens? Again, both sensors will get deactivated. So it will go to again the first state. So in that case, again I will switch on the motor. Inlet motor, outlet motor will be in off state. So the logic is very simple. So when we take an empty water tank, both S1 and S2 will be non-active. In that case, we open M1, we switch off M2. So water gets filled up. When the sensor activates, when S1 sensor gets activated, still we continue with the same operation. M1 is active, M2 is non-active. Once the water gets reached to S2, we switch off both M1 and we activate M2. So thereby water starts reducing. When the water starts reducing, S2 will be in off state, S1 will be in on state, still we continue with the same operation. M1 is off, M2 is on. Once the water again reaches below your S1, we switch off M2, we switch on M1. Thereby water gets into the tank. So this is how a small water tank level control system can be built. So this is shown in terms of a state diagram here. So in the empty state, both sensor S1 and S2 are non-active, which is represented by 1, 1. In that case, I am going to switch on M1 and M2 is going to be in off state, and I declare a variable called as n equal to 0 in this state. So slowly water gets built up, thereby S1 gets activated, S2 is not activated. In that case, again I am going to have the same condition. Inlet motor is on, outlet motor is off. But now I change the variable value to be n equal to 1. As soon as the water reaches 90% water tank, both the sensors will be activated. In that case, I change the logic. Inlet motor will be off, outlet motor will be on. And I define a variable called as out equal to 0. So once the water starts reducing, my sensor S1 will be on, S2 will be in off state. So still I continue with the same combination. Inlet motor will be off, outlet motor will be on. We define a variable out1. So again it goes back to 1, 1. So this type of loop will continue as long as possible. So what happens? We fill the tank up to 90%. After filling the tank, we start draining out. Once it reaches below 10%, again we start pouring the water onto the tank. So this is the simple water tank level control system which we are going to build. So here for programming part, we are going to use Micro C Pro for AT51, where we will be developing the C program and converting that C program into an hexadecimal file. Then we use Proteus 8 Professional for building the circuit. So I am going to use two switches, one at 10%, another one at 90%, connected to port 1.0 and port 1.1. And we are going to use two motors, one motor for inlet and one motor for outlet. Both are DC motors. So in order to connect a DC motor, I am going to use L293D motor driver. The main application of this L293D motor driver is bidirectional movement can be achieved. It also provides an isolation between your rotating device and the electronic circuit, and also it will help in providing the appropriate current to the motor. Thereby it can rotate efficiently. So we are going to control motor 1 through port 2.0 and 2.1. Motor 2 control will be through port 2.2 and 2.3. And we enable both motors through E1 and E2 given to a supply voltage. And we also connect an external supply voltage so that the external power can be delivered to your motor. So here I show a typical circuit diagram where we have connected an oscillator circuit of 10 MHz to XTAL1 and XTAL2. A reset circuit is connected to reset pin. So by default, this pin will be at logic 0. Whenever I close the switch, this pin will go to logic high. Thereby reset operation will take place. Then the two sensors, switch digital sensors, are connected to port 1.0 and port 1.1. When I close the switch, the pins will go to logic 0. Then we have connected two motors and its control happens through port 2.0 to 2.3. Is connected to your L293D and the supply to the motor is connected to pin number 8 of your L293D. So M1 is an inlet motor, M2 is an outlet motor. When you look at the program, I write subroutines for water inlet where I give port 2.F0 to be 1 and 0. So motor will rotate in one direction. Same way for outlet motor, I am going to make it as 1 and 0. Port 2.F2 and port 2.F3 to be 0. Then again two subroutines for stopping this inlet and outlet motor. So by giving logic 1, we can stop the motors. Then in the main program, I am going to declare few variables, character variables, in equal to 0, out equal to 0. Then I say port 1.F0 as input pin, port 1.F1 as an input pin, because these two pins we have connected as switches, S1 and S2. Port 2 I have configured it as output port by giving a value of 0x00. Then in a while loop, I am going to check whether the first state has occurred. In the first state, both the switches will be non-active. Port 1.F0 and port 1.F0 both will be non-active. If both the sensors are non-active, we are activating the inlet of water into the tank. Outlet is stopped. So when the water gets filled up, what happens? The switch 1, which is connected to port 1.F0, gets activated. In that case, I am going to set a variable in equal to 1. When my switch S1 is activated and if in equal to 1, what I do? Still I continue with water inlet and I stop the outlet. So in that case, water slowly gets filled up. What happens? Both switches will get activated. Switch S1 and S2 both will get activated. In that case, I am going to set the variable to be in equal to 0. So when both the switches is activated and in equal to 0, what I do? We stop the inlet motor. We activate the outlet motor. In that case, what happens? The water starts reducing. When the water starts reducing, only S1 will be active, S2 will not be active. In that case, I put out equal to 1. Then I check whether S1 is active, S2 is not active and in equal to 0. In that case, I continue again with same water outlet and inlet motor is stopped. So water starts reducing. So when again becomes S1 and S2 are non-active, I set the output to be 0. So these are the 4 states. So here we have drawn this 4 states: 1 1, 0 1, 0 0, 0 1. So that we try to define it here. 1 1, 0 1, 0 0 and 0 1. So the 4 states are defined here. So this is how a water tank level control system state machine is implemented, and that state machine is converted into a code. Now let us go and build the circuit in Proteus 8 Professional. So here we have connected an oscillator circuit of 10 MHz, reset circuit and 2 switches S1 and S2 connected to port 1.0 and 1.1. And port 2.0 to 2.3 is connected to L293D motor driver, and it is connected to your inlet motor and outlet motor. So the same code is built in your Micro C Pro for AT51, where we have subroutines for water inlet, water outlet, inlet stop, outlet stop. Then in the main program, I configure the port pins. Then I go from one state to another. When both the sensors are not active, we are allowing the water to get into the tank and the outlet motor is stopped. When switch S1 is active, Still we continue with the inlet of water into the motor and outlet is stopped. When both the sensors are active, which means the tank has reached 90% of its capacity, we stop the inlet motor and start the outlet motor. Then again water starts reducing, thereby our S1 will be active, S2 will not be active. In that case, I again continue with the same process. Inlet motor is stopped, outlet motor is on. So after writing the program, we compile the program. By building the program, it gets converted into a hexadecimal file. Once it has been converted into a hexadecimal file, we need to import it to the circuit. Right click on the IC, edit properties, select the hexadecimal file and load it onto your microcontroller. So after loading on, press the play button. So now you can see the water gets flown into the tank. So the inlet motor is active. So the water starts filling in the tank. So now as the water starts filling, the water may rise to the sensor level at the bottom. So I am going to close the switch. So when the sensor is activated, still the inlet motor is on. So still the water gets pumped onto the tank. As soon as the water reaches the top 90% of the tank capacity, S2 will be activated. In that case, what happens? Our inlet motor gets stopped, outlet motor is on. Now the water is getting drained out. When the water is getting drained out, S2 will become inactive. When the S2 becomes inactive, still we are trying to drain out the water and the inlet motor is off. So water starts flowing out of the tank. Thereby once it reaches below S1, again the inlet motor starts. So thereby it starts filling the water into the tank. So this is how a simple water tank level control system can be built using AT89C51 microcontroller. Thanks for watching. Please subscribe for more technical learning. Thank you.